In this video we're looking at the cross-site request forgery labs on DVWA. So we have a security level set to low as usual to begin with, and we have a login form here, or a password change form here. It says test credentials and it asks us for a new password and confirm a new password. So before we do that, let's go and check out what cross-site request forgery is. Let's have a look at Portswigger, as that's generally going to be a go-to resource for anything web security related. So what is CSRF? Cross-site request forgery is a web security vulnerability that allows an attacker to induce users to perform actions they do not intend to perform. It allows an attacker to partly circumvent the same origin policy, which is designed to prevent different websites from interfering with each other. So we have an example here of a URL with a vulnerable website. Let's say it's facebook.com, and then email, and then change email, and then so if you were to supply this link to a victim, the idea is that they'll click on the link and it will automatically go to facebook.com where they're already logged in using some cookies, and then it'll automatically go and fill in the form or make the request to update the email address to the email of the attacker. So then the attacker can then go and log in, or maybe they'll change the password or something like that. So it tells us here that there are 3 conditions that must be in place for a CSRF. So there must be a relevant action, there must be an action on the website that we're trying to get the victim to perform. That must exist on the site. There must be some cookie-based session handling, so it needs to rely solely on session cookies to identify the user who's made the request. And then finally, there should be no unpredictable request parameters. So we need to determine what parameters are going to put in here. So if there's a random token generated each time, that's not going to work for us. And that's the whole idea of the CSRF token. So we, in some of the challenges we've been through so far, if you think back to our brute forcing challenge, we actually went through brute forcing and we would capture the CSRF token using the grep function in burp, and then submit that with each time we make the next request. We would submit the new CSRF token. So there's some really good labs on here. You can see there's a lot of different labs and they get quite complex. So I'll try and come back and run through these at some point. But for now, let's close that down. Let's go back to our DVWA and check the help here. Try and zoom in a bit. So same thing here. CSRF or CSRF is an attack that forces an end user to execute unwanted actions on the web application they're currently authenticated with. With the help of a little social engineering, such as sending a link via email or chat, the attacker may force the user of the web application to execute actions of the attacker's choosing. May also be called XSRF, similar to cross-site scripting and often used together. And it just mentions here that if the targeted end user is an admin, then it can compromise the entire web application. So let's see what our goal is here. The objective, it says, is to make the current user change their own password without them knowing their actions using a CSRF attack. And low level says there are no measures in place to protect against this attack. This means that a link can be crafted to achieve a certain action, in this case change the current user's password. Then, with some basic social engineering, have the target click the link or visit the page to trigger the action. So let's close that down. Let's try and see if we can do the low difficulty. So let's have a look at the form here. If you inspect this element, we have the test credentials function, button on click test func. Okay. We have a script here where it's going to call window open vulnerabilities CSRF test credentials.php. Okay, some of this might be to do with actually verifying that we've done the challenge. Let's hit test credentials. You can see here it's asking for username and a password. Let's log in. Valid password for admin. Okay. Let's have a look at our burp suite. Look at the requests. Have this test credentials. So we make the get request. First we made the get request here and we were redirected. It made the get request to the test credentials, and then it asked us for the username and the password, and then finally it made this post request where it sent our username and password. So let's looks like that's the validation. Maybe let's try and enter in a new password here. Let's say test change, password changed. Okay. let's check out Burp Suite there and see what happened. We had a GET request, and the GET request simply sent off this password new is equal to test, password confirm equal to test. Okay, so if we were to take a copy of that and insert that here, and let's say test 1 2 3, test 1 2 3, copy that. If we were to access that URL, we'll get the password has changed. Let's test credentials and say admin and then test 1 2 3. We can see that the valid password for admin. So let's go back and change our password here, because otherwise I'll forget what it is. It was just password. This is the password that we use to log into the application, by the way, so make sure you know what it is. So we save that. Let's test it again. Admin, this time it's going to be with password, and there we go, valid credential. So essentially that was the idea, is we have this URL, we send this URL to somebody in an email, and they click on that link and it changes their password to our password of choice, and then we go and just log into their user account. And that's essentially that. Let's take a look at the help and see if they suggested anything differently. Okay, so it's just telling us, just giving us the URL. And let's check out the medium difficulty then. Let's go and change the security level, change that to medium and submit, and go back to CSRF. So for the medium difficulty here, if we check the help section, it says medium level. For the medium challenge, there's a check to see where the last requested page came from. The developer believes it matches the current domain. It must come from the web application so it can be trusted. It may require link multiple vulnerabilities to exploit this vector, such as reflective XSS. So to give an example, let's change the password here. Well, the password's already at password, so let's just change it to password. Hit change just so we can get this URL, and what I want to do out of interest is just let's go to our home page, and then let's pretend that we're a victim. Somebody's just sent us that URL and we're going to access it to change the password. We hit that and we get that request didn't look correct. So let's take a look at the requests. The first request that we sent to change the password, you can see here it came back, and this one successfully, where is it, password changed, whereas this one we got that request didn't look correct. And if we look at the differences between the two requests, we can see straight away that there's a header missing, which is the referrer header. So in the first one we had a referrer header to say we're coming from 127.0.0.1, the second one we didn't. So let's just remind ourselves, let's go back to the Portswigger CSRF documentation. If we scroll right down to the bottom, there's a section here on the validation of referrer header. So in some cases, removing the referrer header altogether might bypass the check. In other cases, it suggests here that you could, if the referrer header is checking to see if it contains vulnerablewebsite.com, you could potentially send a referrer header to your attackerwebsite.com, but then have their URL at the end. Just depends how they're actually checking the referrer header. If they're simply checking to see if the string exists within the referrer header, then that attack might work. So worth bearing in mind. In this case, in playing around with this, I was looking to create a form here. You can see we created a form exploit.html, and essentially I took this from, where is it? Let's view the source. We can see here that we have our form to change the password. So I created a short HTML file, and just in the body put in that same form, but we put in our actual URL. You can see here instead of the hash, because we're going to be sending let's pretend that we're hosting this on our server, and instead of it being DVWA.com, it's going to be DVWO.com or something, and we send them the link, and it has this hidden form. So we've changed these fields to be hidden so that they won't actually see anything, and then rather than just the name being set here, we've also set the value to say automatically, and this is the password we want to set, and then we have everything hidden. We just automatically send the form, and then the page should just close. So let's open that in Firefox exploit.html. You can see it just instantly closes. If we go to our but we get this that request didn't look correct, so it redirected us here. Let's go to Burp Suite and we'll see that we got this request, and again the issue is that it didn't have the referrer header here. So we've described one way that we could potentially bypass that. Let's go to our stored. Okay, actually, let me clear that. We haven't gone through the stored XSS yet, as we're working our way down, so I haven't actually done this yet. But what I'll do is just go and set the difficulty to low just while we store our XSS, and not worry about any protections that might be in place here. And we just want to say, hi admin, we have a message for you, and the message is going to be, take a look at this image please, and the image contains our URL, so let's copy that. Okay, we can't fit the URL in. Let's inspect element, set that the max length to 250, and let's just paste that in there again. You can see there we pasted that in. Let's change the password to test123 and test123. Sign the guestbook. You can see here we've got a little funny image because it didn't recognize that image. It actually interpreted it as code instead. And if we take a look at our Burp Suite here, we have a get request. So we had this post request here where we submitted to the guestbook, and then immediately after, let's see the timing on this, 15 seconds past. We have this at 16 seconds past. We have then a request to change the password, and you can see that the referrer header is set from the XSS screen that we were on, but as long as the domain is the same, that's fine. And the response that we got back from that was password changed. So now if we change our difficulty, our security level back to medium, go back to our CSRF page, and we'll go to test credentials, and then we're testing the password here. We can see that's the wrong password because we successfully changed it to test123. So let's change it back to what it should be, password. Close down some of these windows, and let's take a look at the high difficulty level. One thing I forgot to mention there was that the Burp Suite has an option. If you have the Pro version, you can use this in the engagement tools. You can right click on a request or on a URL and select the option to generate a CSRF POC. So if we had a form which we wanted to test out CSRF on, we could automatically generate a we could automate the generation of a new form rather than creating that manually. Unfortunately, I don't have Burp Suite Pro. I would recommend, if you're going through the Burp Suite Academy challenges, see if you can get a trial to go through it. I did have a trial at the time, and it means you can use a Burp collaborator and things like that. But it's quite expensive. I don't have a copy at the moment. Maybe if I was doing some more bug bounties and things, it would be worth it. But okay, just gonna start by just changing the password here. Let's see what happens. We can see here that the request has gone through. It changed the password to password, which it was already anyway. And we now have this user token, the CSRF. So let's check the help. You can see here that, yep, anti-CSRF token has been added. In order to bypass this protection, another vulnerability will be required. So if we remember in the last session, if we go to our XSS stored and put in our name, let's say admin, and then our message, we used an image source. We said image source is equal to, and then we pass in, let's grab the URL, change this again, just change it to password, and we want to grab this whole thing including the token. Okay, we need to expand the size of this. Set it to whatever, set 500. And I'm going to do that again. We need a backslash first, and then that has that full token in it as well. We'll save that, and then close off the tag. And if we sign, The issue is here we get nothing back. It's not actually displayed to us because we have the security level set to high. So if we go back to our security level and set the security level to medium, in fact, just before I do that, security level on high. Ideally, what we'd be looking to do here is we'd be doing. Okay, it's really annoying that the size of that. Let me paste this into Sublime. Okay, so ideally, what we'd be looking to do here is instead of sending this user token, we would say user token is equal to and then plus, and then if we go in here and go to our CSRF, we can see that, or even we'll do right here, we'll do our console and we'll say console.log documents dot get elements by name, and we know that the name is user token. We can double check that. We can go to the source or inspect element, but we'll see there isn't a user token on this page. So let's yeah, so there's no nodes on this page. Let's go back to our Site Request Forgery page. So this is on high. Let's do the same thing. Console.log document dot get element by name. We give it a user token, and it gets back a list of 1. So let's check out the first element. You can see here we've got our token, which if we view the source, our token's right here, and it's going to change each time we refresh the page. You can see. So we could be essentially saying, well, we want to do that and then grab the value of the token, and it's going to print out this value each time we do that. So if we were able to just grab this and send that to the user, then it would be sending off this token as well for them. The problem is, as we kind of saw there, that the XSS stored doesn't actually take that now. If we go and, because it doesn't have the CSRF token there. If we go to set this to impossible, go back and submit. Now go to our XSS stored. We'll now see, if we check the source here, that we have the user token. But the problem is now that it's impossible. There's no way for us to inject our script. So if I put in here hi, we expand our max length and submit that, you see that it doesn't even submit our request. Oh, we got their CSRF token is incorrect. Oh, so we need to actually send off the CSRF token with this request as well. But so that's the issue in terms of trying to get this done. Obviously, the solution really here. Okay, this is set to impossible. Let's go and set it back to high. And the solution here obviously would be to, let's change password to password. Grab this URL, and if we were to send this URL to a victim and have their token, so if we had some XSS we could use, or we tricked them into revealing their token to us, then we could just grab their fresh token. Let's refresh the page here, and let's assume that we've done some XSS injection here, and say document dot get elements by name user token, and let's grab our value, paste that in here, and change our the password to test123. Test123. We send this to our victim and say, hey, have you seen this cool news article? It's not dodgy at all. And then they go to the page and see this. What's this? Password changed. Uh-oh. And now if we go to test our credentials, we're trying to log back into our whatever this was, Facebook or something, and we log in with our saved credentials and we have the wrong password because we clicked on that link. But this obviously requires getting this token. XSS, I mean, I'm going to go through the XSS sections later, so I guess we'll leave it at that, but we could have done it quite easily if the tokens were available on that XSS page on the same difficulty level. But yeah, let's change the difficulty to impossible anyway, and let's just see what we have here for the CSRF. Close these down. And so for impossible, we can see straight away the issue here that we need the current password in order to change the password. So if we put in, actually we need to reset our password anyway, so we'll put in our password test123, but then we put in our new password and we confirm our new password and hit change. And you can see that if we had let's put this into Sublime, if we had a victim and we wanted to send them this URL, we wouldn't be able to just automatically send them because we'd need to complete this password current. Let's try and send that again now that we've changed, and we also need the user token as well, but let's even assume that we have the user token. Let's grab the user token now, the new one. Let's assume that we got this user token, which obviously is just as hard to get. Well, not just as hard to get, but it's hard to get. But let's assume we got the user token, we didn't know the password, so we send that to the victim, they open that, and then the CSRF token was incorrect for that one. Okay, well it would basically say that our password was incorrect anyway. And that's the impossible difficulty. Let's go and double check, see what they say here. And the impossible level of the challenge will extend the high level, I guess, and ask for the current user's password. As this cannot be found, only predicted or brute force, there is not an attack vector here. Cool. So yeah, that's the CSRF category. I hope you've enjoyed this video. If anybody has any cool solutions for the high difficulty, I would be interested. I know we could potentially maybe set up a bigger JavaScript exploit and inject that and we can run like a Python server with Python -m http.server say 9999, and we could just have our script here and just have the script source set to that script. If we wanted to send in more or try to bypass some of the filters for the XSS on the hard mode, but it'd be interesting to see if anybody's got any cool solutions to that. Let me know.